Okay, so yesterday we looked at parametric equations. Today we're going to look at, okay, what's a little different about polar is that we're going to go back to just one equation. So when you want to draw something in polar, you only need one equation. But it doesn't use the same kind of grid, okay? We're used to the kind of grid where you've got x and y axis, and you have square blocks on the grid. Well, this polar grid is circular. Okay, so I'm going to show you how, today we're really just going to focus on how do you graph a single point in polar. Not even a whole equation, just one dot. Okay, and I'll show you how to do it. Okay, so up until now, everything we've done, at least in this class, has been a rectangular coordinate system. Usually it's called an x and a y axis. But the reason why polar comes in handy is because there are some graphs that are extremely simple to draw in polar. There's also some things that are hard, right? You kind of use whatever graphing system you need to make your life as easy as possible. So I'm going to show you 3 different pictures. Okay, well, actually, they're going to be the same picture, but I'm going to show you how to do it 3 different ways. Okay, kind of from hardest to easiest. Okay, and I'm going to draw a circle. So, let's draw a picture of a circle. Now, if I want to draw a circle as a function, okay? Now, think about a circle. Does a circle pass the vertical line test? No, it fails it. So technically I can't really draw a circle, but I can kind of cheat and draw like the top half and then the bottom half separate. Okay, so if I wanted to draw a circle, we can just pick any radius. Let's do 3. Right. This is how you draw a circle with a radius of 3. You would have to do the square root of 9 minus x squared. But that's only going to give you the top half. Right? Now if I wanted the bottom half, I would have to do the negative square root, 9 minus x squared. So kind of a lot of stuff to type in just to graph a circle. Okay, and that's the best I can do. It doesn't even connect if you look closely, but I can't do any better than that. Okay, so that's a circle. And here was the equation that we used. Okay, any questions on that? That was function. Okay, so the next mode we learned about was parametric. Right, so let's switch over to parametric. Let's draw a circle there. Okay, so in parametric, that's where you type in 3 cosine t, 3 sine t. Okay, you can pick any number. I'm just doing 3. And there's a circle. I think that's a little bit easier. I think that's less stuff to type in, and you get a nice circle. It actually connects. It looks like it should. Okay, so there's a circle. And here's the equations that I used. All right. And that's parametric. So, a little bit easier. Still uses trig functions though, so if you don't know trig, you can't really draw a circle in parametric. Now, let's look at polar. Polar, this is a mode I haven't shown you yet. So when you go to polar, instead of saying y equals, it says r equals. There's only one equation per color, so you only have to type in one thing. And if you want to draw a circle with a radius of 3, that's all you type in, the number 3. So, polar, very, very simple to draw circles. Okay. And that was a 3. So if polar is very good for circles, what do you think polar is probably not as good for? Lines. Okay? Polar is really designed to draw things that are circular. Can you draw lines in polar? Yes. But it's kind of like drawing circles as functions. It's more complicated. Okay? Lines go with function. Y equals mx plus b. Simplest way to make a line. Circles, you'd go with polar. Right? So that's one advantage of polar. Easy to draw certain shapes. Okay, so this is what polar graph paper looks like. On yours, I don't think you have as many circles. But the idea is that you really don't call it the origin, you call it the pole. If you call it the origin, it's not a big deal. But it's called pole. And this axis is called the polar axis. When we get into sketching and you have an angle, every angle is measured off the polar axis. Okay, and we'll go through that. That's where your angles are measured from the polar axis. So in polar, okay, different kind of graphing system, different kind of coordinate. You do not have an x comma y. That's rectangular, that's function. Okay, we're not doing x, y. In polar, you have an r and you have a theta. Does anybody have a guess what the r would stand for? Yep, it stands for a radius. And theta, we usually use that to represent an angle. Okay, so in polar, you have a radius, which is the distance from the origin, or you can also say the pole. And you have an angle. Okay, so a coordinate in polar would look like this. 3, 30 degrees. That's an example of a polar coordinate. All right, so I'm going to show you how you graph a point in polar. What it's really going to depend on is you have to look at r. If it's positive or negative, you're going to do something. And then theta. If it's positive or negative, you do something. Well, r is kind of like x. If r is positive, you're going to start at the origin, and you're going to move right r units. That's not the final answer. That's just the first part of the coordinate. Move to the right, r units. If r is negative, you're going to move left, r units. So that's exactly how you would treat an x value in a coordinate. Okay, so we either start out going to the right or to the left. Now, theta is an angle. When we talk about movement on an angle, circular movement, we don't really use the terms up, down, left, and right. What are the two directions you can move if it's circular? Yep.
Clockwise and counterclockwise?
Yeah, clockwise and counterclockwise. Which way you move, it depends on if your angle is a positive or a negative. So if your angle is positive, you're going to go clockwise. If your angle is negative, you're going to go, if your angle is positive, you're going to go clockwise, counterclockwise. Just write, what I have written is correct, don't listen to me. If your angle is negative, you go clockwise. So greater than 0, counterclockwise. Less than 0, clockwise. And that's after you do step 1. So handle r first, then handle theta. Okay. So we'll look at all the different cases. Right? What if r is positive and theta is negative? What if they're both negative? What if they're both positive? Okay, we'll try all the different cases. Okay, so that's the first thing we're going to do. We'll graph some points, and then the last thing we'll do is we're going to learn how do you take a point that's in polar and convert it back to what we're used to. How would you change it back to xy? Okay, we'll go over that too. Okay, let's look at graphing first. Now, if you only put one problem on each graph, you're going to run out of graphs because you only have 6. what I would probably do is use the same graph over and over, and then you can just label it. Oh, this was example 1, and this was example 2, example 3, you know, something like that. And then off to the side, just write down what the examples are. But you can do it however you want. Okay, so let's look at the point. 3, 45 degrees. Alec, what's my radius in that point?
3.
3, yep. And Isabel, what's my angle? Yep, 45 degrees. So let's start with the 3. Isaac, since the radius is a positive 3, that means I'm going to start at the pole and go which way 3 units?
To the right.
Yep, to the right. I'm going to put a temporary mark here. I'm going to erase that in a minute. Okay, I'm just putting it there to remind me, okay, that's where I start from. Now I need to move 45 degrees, and I have to think clockwise or counterclockwise. So Nick, which way do I move for this one?
Counterclockwise.
Yep, counterclockwise. So 45 degrees is exactly halfway through the quadrant. Now, on your graph paper, if you look at the lines, I think it's set up kind of like this graph paper. I think each line is 15. So 0, 15, 30, 45, 60, 75, 90. You can double check, but I think that's how it's set up. So when you get the lines, that makes it a little easier. If on the test you get a blank kind of grid like that without lines, just estimate it the best you can. 45 should be in the middle. So if you put it down here, I might give you half credit because you're on the right circle, but you're not on the right spot. Okay. Any questions on graphing? Okay, let's try this one. -2, 75 degrees. Jaden, what's my radius here?
-2.
Okay, radius is -2, which tells me I'm going to go 2 units which way? To the left. So we're going to start by going 2 units left. Why did she go left and not right? We went right on the last one. This one's negative. So 2 units left. And Connor, now I have to move how many degrees?
75.
75. Which way?
Counterclockwise.
Counterclockwise. So 75 degrees is almost all the way through the quadrant. So you should end up, I don't know, about right there. Okay. So that's 75 degrees counterclockwise. So remember, this is your polar axis. Every angle is measured from that axis. Okay, whether you go right or you go left to start. Okay. Questions on that one? Okay, let's try this one. 3, -60. Okay, so now we got a positive radius, negative angle. Rebecca, can you tell me first thing I would do to graph this?
Go to the right 3.
Yep. So we're going to go right 3. And now I know I'm going to go 60 degrees. But the question is which way? 60 degrees. Clockwise. Right, so 60 degrees clockwise. Go like halfway. And then just go a little more. Okay, so you can put that on your grid. I think it'll end up right on the line. But on mine, that's where it is. Okay, any question on that? All right. So besides the fact that this is a negative, we haven't done one yet, what else is different about it? It's in radians. If you can graph it in radians and you can do it, that's fine. If you need to change it to degrees, that's fine too. When you change it to degrees, if you do that, what would stay the same? The negative what?
-4.
Yeah, the -4, that's a radius. Okay? That doesn't change, ever. Okay? So -4. What's -3 pi over 2 in degrees? Yep, -270. Good. So now this time when I draw it, I'm actually going to trace which way I go. Starting from the pole, we're going to go 4 units to the left. Okay? So 4 units left. And then 270 degrees, which way? Clockwise. So that's like this. Well, this one I'm going to show you something. So you don't normally have to trace it, no. Okay? Can somebody give me another way I can get to that same point besides -4, -270? Yeah.
-4, 90.
All right, let's try it. -4, 90. So -4 and then 90 counterclockwise. Yep, that works. How about another way? Yep, Michael.
4, -90.
All right, let's try 4, -90. So now we're going right 4. Right 4 and then -90. Yep, looks good. And one more. So you got the negative, you got the negative positive, you got the positive negative. We don't have positive positive. That's the last one.
4 and then 3. 5.
4 and then 3 pi over 2, which would be 270. So right 4, 270. So based on what I just did there, how many different ways are there to get to a point in polar?
4.
Yeah, at most there's 4. Sometimes there's less. If a point is right on the polar axis, you usually only get 3. Because like if you had a point here, you could go just that way, you could go that way, and that way. There's only 3. Okay, but if you don't have a point on the polar axis, in general, there are 4 different ways to get to it. You can choose to go left or right, and then from there you can choose clockwise or counterclockwise. Now, some people say, what if you did something like this? You go right, you go around, and then around, and then around, and then stop. That's not really a different way.
It's the same way.
It's the same thing. You just went around 3 times instead of stopping. You still went right, and you still went counterclockwise. So the 4 ways: right clockwise, right counter; left clockwise, left counter. Those are the 4 ways to do it. Now, compare that to this. Let's look at what we're used to. What's the coordinate for that point right there? 4, 2. What's another coordinate to get to that point? There isn't. Okay, there is only one way. When you're doing an XY graph, if you want to get to a certain spot, there is exactly one way to do it. In polar, there's 4. Okay, so that's a big difference between polar and rectangular.
Is it because of like the sections?
Well, it's because of the
Quadrant
movement.
one. Oh.
It's because of the way you move on an XY axis. Your choices are left, right, up, and down, and you can never, like if you move clockwise or counterclockwise, think about a circle. You can get to the same spot going different ways. But if I said, all right, you can move left or you can move right, can you get to the same spot? Not really. You go left, you go one way, right is the other. But clockwise and counterclockwise are really the same path you travel, just a different way of traveling it. It's not like that in rectangular. Okay, so let's graph the point 0 pi. Okay, what do you think is going to happen here? Yeah, my radius is 0, so it's going to stay. It's going to stay right at the origin. But what's my angle? pi. So pi is what in degrees?
180.
180. Okay, so what you got to do is go like this. You've got your point. Okay, this is good. Watch this. Hold on. You got to take, and you just want to rotate it 180, like that. Just make sure you rotate it.
Get fancy on us.
Not
expecting that.
So how are we going to show that on the test?
Good question. So on the test, what I'm going to look for is the SF. Spin factor. So when you put your pencil down, I'm going to look and I'm going to be able to tell how much you spin it. I'm going to look for the spin, so I can tell if it's, you know.
Wait, no!
What?
I didn't look at the top.
Am I serious?
Should I write that?
I wrote it.
Can I get a Beyblade?
So the point,
Are we going to tell you on the test? Or are you not going to give us one?
as far as graphing it,
Right.
no, you just put it at the origin. You're good. Right? It spins in place. If you want to put your pencil and spin it, you can go for it. It's more fun that way. But otherwise, just put it at the origin and you'll be okay. All right? So 0, comma, anything is at the origin. How about this one? This one has a 0, but it's 2.5 comma 0. Is that at the origin?
No.
No. If the second number is 0, all you're going to end up doing is moving left or right. So your point is on the polar axis. In this case, where's 2.50? Left or right?
Right.
It's right. Now, how do you estimate 2.5? Just go in between the second and third circle. Okay, just like you would if it was rectangular. Okay, so we've gone through pretty much every case. The positives, the negatives, zeros, spin factor, everything.
But now,
Questions on graphing points in polar? Okay. We just did one like that. So I already pointed this out to you, but when you do graphing, there is more than one way to get to the same point. Okay, and the reason I show you the 4 different ways is because, let's say you do a problem on the test, and it says convert a point to polar, which is what we're going to do next. And you get this as an answer. And if it's multiple choice and you don't see that listed, well, maybe one of these other ones is listed, right? So you just have to know if you get a point in polar, there is more than one way to write the answer. And as a multiple choice question, I tend to lean towards the positive. I think that's usually the simplest way. But there are other ways. You could come up with formulas to figure out all the different ways. Like you could say something like, all right, if you've got a positive radius and a positive radius, just take the one that has the negative angle and add 360. And that'll give you the positive. So you could try to figure out shortcuts, but what I usually do is draw it. Then I can just look and say, okay, I got to go this way or that way. So I just look at a grid. To me, that's the easiest way. Okay, so last 2 things we're going to look at is how we change a point from the new system we're working in. What are the 2 letters that a polar point has?
R and theta.
R and theta. Back to the system that we're used to using. What 2 letters does the old system have?
X and Y.
X and Y. So the goal here is to take an R and a theta and change it into an X and a Y. So to do it, at least the first time, we're going to make a picture. What do you think is going to be in the picture that I draw? A point? Yes, there will be a point.
A circle.
There'll be a circle, and there's going to be one more thing, our favorite shape.
Right square.
A right triangle. No, we don't like squares. A right triangle. Okay, so we've got a circle. Okay, this could represent, maybe there's a bunch of circles. It doesn't matter, but you've got a point somewhere on the circle. Let's put it right here. Now in polar, you would know this. Okay? Just to make it visual, this is r. It's the distance from the point to the origin. Theta is the angle right there. Theta is the angle between the diagonal and the horizontal. So how am I going to make that into a right triangle? Yeah, I'm just going to draw a line straight down like that. And that is my right angle. Okay, so you would know that piece of information, which is how long that is, and you would know theta. Now, what do we normally call the bottom distance on a triangle if it runs horizontal? We have a letter we normally use. X. Right? X is the distance from the origin to here. Now, what do you call the distance from here up? That's y. Okay? So our goal is to figure out x and y based off knowing r and theta. So let's start with x. We want to find x, and you're going to be given this and that. So first thing you want to think about is look at x. What position is that side in? Now, what's its name? I know its name. Its name is x. But what position is it? Yeah? It's adjacent. Let's look at the other side I circled, r. Okay, so that side is named r. What's its position? Yeah? Hypotenuse. What trig function involves adjacent and hypotenuse? Cosine. So you're going to write down cosine of, what do you put in? Cosine of theta, always cosine of your angle, equals, and we just did it, adjacent over hypotenuse, x over r. Now, my goal is to take that now and get x by itself. So how would you get the r on the other side? Multiply by r. Multiply by r, and there is your formula for x. So if you're given an r and a theta, and you want to know the x value, take the cosine of the theta first, and then times it by r. Any guess what the formula for y is going to be?
R sine theta.
Yeah, it's going to be r sine theta. So now if you want the y value, take the theta they give you, take the sine of it, and then multiply by the r value. Any question on that? Okay. Now there's two kind of special numbers that could come up here. When we did unit circle trig, what angles were considered special? If they were multiples of what? 45 and multiples of 30. Okay? Two special numbers come up when you deal with those triangles. This number can come up, and this number can come up. Now, if you don't... What? Okay. So, if you don't remember unit circle trig, you can study it again, which that would be fun. Or if you can remember, actually I just know what they are. This is about 0.707. So if you do a calculation and you see the number 0.707, that's that. Okay? If you see the number 0.866, you want to write that. Okay? The only time you're going to see one of those numbers is if they give you an angle that's a multiple of 30 or 45. If they give you an angle that's anything else, you can just write whatever decimal you get. These are the only two special ones. 0.707, 0.866. Now, it could also be negative 0.707. So you just put a negative in front. Right? That's pretty much the same thing. Okay, Let's look at this one. Yes?
Square root of 3 divided by 3 is 0.57.
Oh. 2. Change that 3 to a 2. Thank you. Square root 3 over 3, that number comes up when you deal with tangent. We don't need tangent. So that square root 3 over 3, 0.577, that is a special number. It's not one you need to worry about. Thank you. So square root 3 over 2, not 3 over 3. And that will be 0.866. You can double check me if you want.
No, I knew it was off.
Yeah. Okay, now look at this angle. 200, negative 200. Is that a multiple of 30?
No.
No. You can't multiply 30 by a nice number and get 200. You can do 30 times 6, you can do 30 times 7. Those don't give you 200. Is that a multiple of 45?
No.
No. 45 times 3 is 135. 45 times 4 is 180. 45 times 5 is 225. So this is not a multiple of 30 or 45. You don't have to worry about these numbers in this problem. They're not going to come up. So whatever decimal you get, just write it down. So, start with x. What's my formula to find x? Yeah?
Negative 200 cosine.
I like cosine. That's good.
I mean 2.
2 cosine.
Theta.
And what is theta?
Negative 200.
Okay. I'll do that out in a second. What's my formula for y?
2 sine negative 200.
2 sine negative 200. Now, technically, it doesn't really matter if you put the negative in on the 200 for cosine. Just put it, don't start ignoring negatives when you're not sure if you can, but you actually can then. 2 cosine negative 200. Okay, before I hit enter, one thing I gotta fix.
You're in radians.
Yeah, I'm in radians, this says degrees. So let's go mode, put in degrees, hit enter, and you get about negative 0.188. Okay, and now let's type in y. Just change cosine.
Being in polar, does that affect those manipulations?
No, the only thing that would be affected in polar is when I hit graph. Yep, so being in polar doesn't affect it. No, that's a good question. 2 sine negative 200, you should have gotten negative 0.68, about 0.68. Okay, so final answer, you usually see it written like this. X, comma, y. So if you wanted to get to this point on a rectangular grid, that's the coordinates to do it. Okay. So really all we did was find two sides of a triangle. The base and the height. Questions on that? Okay, let's look at this one. Okay, same directions. What's 5 pi over 6 in degrees? How about, let's start with this. What's pi over 6? 30. Now, this is 30 times 5. That's 150. So, just think about the calculation I just said. 30 times 5. Is 150 a multiple of 30? Yeah. 30 times 5. So, this is a multiple of 30, which means when you do this one out, you are going to see one of these numbers pop up somewhere. So if you see one, we need to write it either as this or that. Okay? So one of these is going to come out nice, the other one isn't. What's my formula for x?
3 cosine 150.
3 cosine. Yeah, I'll just leave it as 5 pi over 6. That's fine. And what about for y?
3 sine 5 pi over 6.
Yes. Now, my suggestion is do not type all that in at once. If you type it all in at once, you are not going to recognize these numbers, okay? Because you'll be tripling them. So don't type in the 3 yet. Let's just do cosine 5 pi over 6. 5 pi over 6. Now, it's okay to leave it like that, but what do I have to do on my calculator?
Change it to radians.
I gotta go back to radians. Okay, so cosine 5 pi over 6, negative 0.866. So that is something special. So I still have the 3. Didn't do anything with that yet. What's negative 0.866?
Negative, square root of 3 over 2.
Yes, negative, I'm just going to put that right there, square root of 3 over 2. That's the answer for your x. Okay. So if you want, I mean, you can just write it like this, negative 3 root 3 over 2. Right. Now the y is going to come out to a nice one. Sine 5 pi over 6 gives me 0.5, and if you triple it, 1.5. So the y, pretty easy. Any questions on the x, how we got that? We did this part first, and we got negative root 3 over 2, and then we just stuck the 3 in front. Okay, that's how you'd want to do it. But only worry about that if it's a multiple of 30 or 45. Okay. Any questions before we look at the last one? What? This was the last one? Yeah, it's exciting. We're almost done. All right. So the last one is basically just doing what we did in reverse. Okay, we did polar to rectangular. Now we're going to do rectangular to polar. If I give you a point in rectangular, what 2 letters am I giving you? X and Y. If I would like it in polar, you need to figure out the what and the what. Radius and the theta. So, to do this, we're going to draw a picture. What do you think is going to be in my picture? Yep, there'll be a triangle.
Possibly a circle.
A circle.
Point.
And your favorite thing, a point. So there we go. It's the same picture I had before. Except I'm going to circle different information. This time, I know this, and I know that. Well, if I give you the x and the y, how could you get the r? Yes, and I'm going to write that down nicely on the next page. You use Pythagorean Theorem. So Pythagorean Theorem will give you r. There's the first thing. Second thing, I need theta. What's the position of this side? Opposite. What's the position of this side? Adjacent. What trig function involves opposite and adjacent? Tangent. Now, tangent is opposite over adjacent. But I don't really want tangent theta. I want theta. So how am I going to get rid of tangent? Yeah, I'm going to take the inverse and I'm going to write that down on the next page. Okay. So, if you want to convert a point from rectangular to polar, first thing you have to do, you don't even really have to graph it. All you have to do in your head is figure out what quadrant the point is in. And you might be wondering, why is the quadrant important? Well, that formula you guys just told me, inverse tangent y over x, that formula works fine as long as you are in quadrants 1 and 4. Because whenever you do inverse tangent, you always get an answer between negative 90 and positive 90. That's from here to here. Inverse tangent is just built in a way that it never gives you an answer on the other part. It's always between negative 90 and 90, which is quadrants 1 and 4. But you can definitely have a point in quadrants 2 or 3. And you just have to make a small adjustment. You still have to do inverse tangent y over x. But if your original point that you're trying to convert is in quadrants 2 or 3, add 180 to the final answer. Or if you're doing radians, add pi. Okay, so you only got to do this plus 180 thing if you're in quadrants 2 and 3. So now, this tells you how to find the angle if you're in quadrants 1, 2, 3, 4. Where else can you be besides quadrants 1, 2, 3, and 4? Can be on an axis. Let's look at this point. That point is on the y-axis. What's the x value of that point? 0. I don't know the y value. Maybe it's up 5, maybe it's up 6, who knows. But I do know the x value is 0. Now, if you have an x value of 0, and you try to plug it into either of those formulas, what would happen? Yeah, you'd be dividing by 0. You can't do it. So those formulas don't work when your point is right on the axis. So how do you figure out the angle? You just have to memorize these 4 numbers. It's either 0. If you go straight up, it's 90. Left is 180. Down is 270. We've been doing that for a few months now. Now, how can you tell quickly that a point is on an axis? Like if you just look at the numbers, what would happen if it's on an axis?
One of the values would be 0.
Yep, one of the values would be 0. 0 comma something or something comma 0. So if you have to convert a point that has a 0 in the coordinate, super easy. Angle's going to be one of those 4 numbers. If it's not one of those 4 numbers, use those formulas. And then the last thing you have to do is find your radius. That's just the Pythagorean Theorem. Same formula in every quadrant. R squared equals x squared plus y squared. Doesn't really matter if x or y are negative, because you're going to square them. Negative's just going to go away anyway. Okay, so we'll try an example of that, and see what happens. Okay, so it says convert to polar. Second one, that one's super easy, but let's do the first one because that's a more typical problem where you got to kind of go through all the steps. Let's start with finding r. What theorem do we use to find r? Yeah, so it's r squared equals x squared plus y squared. So that's the square root of, what's 9 and 25? 34. So r would be square root of 34. We can just leave it like that. Okay, or if you want to round it, I mean, you can do that too. 34 square root. It's about 5.83. Okay, so that's r. Now, think about the quadrant. What quadrant is 3, negative 5 in? 4. Yeah, somewhere right around there. It's right 3 down 5. If you're in quadrant 4, do you need to add the 180? No. It's just inverse tangent y over x. And now we just type that in. Now, whether or not you use degrees or radians, that's up to you. I'll do it in degrees. The only time you have to make sure you're in a certain mode is if the directions say to you. Okay. Inverse tangent, negative 5/3. So we get an angle of negative 59.04. So I've got my radius, I've got my angle. Just write the final answer. I'll put it over here. Yep, because remember, how many different ways are there to write a point in polar? 4. So I'm doing the one with a negative angle because that's what the calculator gave me, and a positive radius. Yeah. R, comma, theta. Now, if you want to convert that to a positive, you could add 360 to that and make it positive, positive. You could make R negative and do it that way. Okay, I'm not going to go through all 4 ways. I'm just going to leave it like this. Any question on that one? Okay, now, last one. How do we know that this is on an axis? This is 0. Okay. Where is 0, 6? Up. It's up 6. What's the angle when you go up? 90. Done. You don't need inverse tangent. None of that stuff. So your angle is 90. Now, your radius is the distance from the pole to your point. It's 6. I mean, you can do Pythagorean Theorem, but it's just going to be 0 squared plus 6 squared equals r squared. You're just going to get 36 equals r squared. Distance is 6, and you're done. R, comma, theta. How many different ways could I write that? Yep, 4 different ways. 1, 2, 3, 4. Okay, any questions on that? Okay, so now we know how to convert between rectangular and polar, polar to rectangular. We know how to graph single points in polar. Tomorrow we'll get into some sketches on the calculator. Okay, so homework tonight, it's 1 through 14 all. So just 1 through 14 all.